The goal of this video is to introduce how to set up and run several Climate Studio simulation workflows, not discussing in any way analysis, only how to run them. So let's introduce my little model here. I've got a site which consists of ground and context building. I have a project which is a massing individual surfaces, so it's an extrusion that was exploded. And then I have two possible glazing sizes for the south side. I have a floor that I then offset and made a second surface that we'll use as a work surface for our daylighting and glare studies. The first simulation we'll set up is the site analysis. To run a site analysis, to do really any simulation in Climate Studio, we need a climate file. We set that up by going to the Earth tab, selecting the folder, and either downloading a file or just using these. There's a ton of files that are pre-loaded with Climate Studio. So I've chose New York Central Park. I'm going to go turn on my sun. We have quick access to both solstices, the summer and the winter, and we can click through the typical 9, 12, 3 summary hours that we use in these kind of simulations often. We can, of course, either look at the site alone or with a context building. You learn a lot more when there's a context massing because that's really what we're concerned with, not what's hitting the site, but what's going to hit our building. We can also turn on the sun path. This is easy to move by setting the position. We can also change its size. So it can be adjusted to whatever. You can custom model it for your needs. It's a powerful graphic because we can quickly see the effect of the movement of the sun throughout the year in a summary image. Let me put it at 12. And then we also have the old school 2D solar window diagram down here that we can print out. And this, of course, changes as I change. So notice, it's the same as the 3D. If I change it to 9 a.m., it's the path changes. We also have access to the wind data in the climate file through this wind rose. This can be also placed wherever by setting the position. And we can change the size of both the interior radius and the exterior radius. So that's a subjective, your own decision. I often use a point to place this so that I can move the point around and easily set the wind rose where I want it. You can adjust what part, how much of the year is being displayed at a time. Remember that you often think about wind in terms of if it's cold, you don't want the wind. If it's hot, maybe you do. And so it's often best to have to display summer or winter or heating or cooling seasons is a more accurate way of putting it. So for example, if I was saying my winter cooling season, I could look this up and be more detailed about it, but this is not a bad winter approximation. And then if I switch it to something that's more during the cooling season, we see we get a very different profile. You always want to be reminding yourself what these things mean. It's not just a pretty graphic. The colors are the wind speed and the obviously the direction is coming from, and then the length is the number of hours, and this is the percentage of hours of the day. are in concentric rings. And then we also have access to various charts that we talked about last semester. So if you don't know what these mean, you should ask me, because you always want to be reviewing this stuff. I know there's no way you can. It took me years to learn this at the level I know it now. Don't expect yourself to understand it immediately, but keep working at it. By the way, I just realized that whole time I was in SI, which is the metric system. In this class, I'm asking that we stay in IP, inch pound, because we live in the United States, and that's what we're using here typically. Okay, so that's the site analysis tool in quick summary. Let me turn off my windrows. Let's do a radiation map now. So I come to my drop-down. That's again why I like using Climate Studio in this way. It's very easy to switch between simulations, and you'll see the more you use it that a lot of the settings are the same. So once you get your model set up, you can easily iterate and continually go back to, wait, let me check the radiation map now. That's the whole point of this, is to set up your model so you can quickly investigate and reinvestigate and iterate. Okay, so I'm now in the radiation map settings. I guess I'd done this earlier, so let me turn these off so we can start from scratch. Okay, so with a radiation map, you need to. There's two types of surfaces that we want to consider. One is, and I'll do those first. I'm going to turn off my site model. I want to know the amount of sun hitting all of these surfaces. This is the massing of my building, and so I want these to have sensors set on them. So I'm going to add analysis surfaces, and we'll see what happens. I'm going to set these 5 feet apart. So these black dots are little fake sensors, and so we're going to measure the amount of solar energy hitting this surface at each of these black dots. And so that's the little scientific experiment we're running. We could then, so the point is right now, let me just go ahead. I'm going to turn on my site, and I'm going to run a radiation map. I'm going to name this one R no site. Actually, it's probably better like this. And there are my results. Remember, you can set the range down here for if you think you want to change it. You can. There's different color spectra that you can use. This is all subjective. You're setting that to make clear the data that you're presenting. But this is all based on these numbers here, right? The first thing to point out is that right now, what are our options here? Because I ran this simulation with individual work surfaces. You call these analysis surfaces or work surfaces. I have access to each individual surface. And so if I scroll up here, you can see that I've got, and I should probably come back and name these if I were really going to use this. So if I come back to here and I click on each of these, this is the south. Number 2 is the south, so I could just change this to 2. This 2 to south. Right, and so I could go and name all the different surfaces in a way that made sense. Now I'm going to go back to my results. I guess I didn't hit enter to change that. But anyway, so the point is if I mouse over these, it will change which surface I'm looking at. And so anyway, that's as I mouse over each of these sensors, it changes the display here. Right now, we're looking at all conditions. That might be of use, but more often for me, it's important to understand is the sun, how much sun's hitting when it's warm outside, in other words, when it's a cooling season, or when it's cold outside, it's a heating season. And so I can select those options and make comparisons based on that, which is, there's a lot of information here is the point. You also can choose either direct solar exposure or indirect solar exposure or total. So direct, remember, is this is direct normal, and so it's basically the idea that whatever, if the surface were pointing directly at the sun with no clouds, how much sun would be hitting it. And then indirect is the amount bouncing off of clouds. So if we're in a climate that has more clouds, we're going to have more indirect than in one that doesn't have clouds. This is one simple way of summarizing it. So yeah, the point is you have a lot of information here, and you need to spend time playing with these and understanding what they're telling you so that you can get useful information out of it, not just run them. But okay, so that's the basic radiation map. But, one thing these are all exactly the same on each face. It's what we would assume, because if I go back to my site analysis and I turn on my site map, we can see that there's no, if this is summer and this is winter, sun, let's go to noon, that, oops, the sun never gets anywhere near coming to the north side. Let me go ahead and switch to warm hours. And so we would assume that there's going to be more sun on the south always. I'll go to full year now. Than on the north. But it's weird that there's just one. Every single one of these sensors has the same value. Why is that? Well, it's because we don't actually have the context on. It's on in the graphics window, but the simulation's not seeing it. And that's because it does not have materials applied to it. So I'm going to come and select my context and my ground layers and put a material on. I'm just going to go quickly put some kind of concrete on both of them. I could get more nuance with that. All these materials are doing is setting an amount of these physical variables. And in our case, for this situation, it's mostly going to be how much reflectance the material has. So I've selected that. And now I'm going to rerun my simulation. Go back to radiation map. And I'll name this our site. And the point is we see that we get a considerably different view. And that's because now the ground is reflecting sun and this context building is blocking it. So we get a variety of values on these sensors. So right now, without the context, it's all the same pretty much. And then with the context, we go 310 to 364. Then of course, if this were a real model where we had more context around, this would be true of the other faces also. So the point here is you got to make sure that you have both surfaces that you want to understand how much sun is hitting it, or simulate a measurement of how much sun is hitting the surface, and you need to have all the parts of the context that are going to block or reflect the sun. Okay, so that's a radiation map. Next, you've been asked to then go quickly inside. So the point is we're doing this at a very early point in our design process, and we're trying to learn. We're trying to get information so that it can help us inform the design. At this point, even we can say, okay, I'm going to now look at the amount of light coming in through glazed openings. By the way, if I go to my results and I click these double white arrows, it turns off my simulation results, so I don't have to look at them. Okay, we talked last semester about the difference between solar heat and visible light. You should ask me in class if you don't remember that, and that's completely understandable. It takes a while to learn these things. But the point is now that we're going inside the building, we're going to look at the amount of light hitting surfaces. That's different than heat. And so the measurement is not going to be kilobtus per square foot or kilowatt hours per square meter. It's going to be lux. And lux is a unit that is calibrated to how our eyes see light. All right, so let's go to a shaded view, ghosted view here. I'm going to turn off right now the site just because it'll make it easier. So as we said, we have our opaque envelope and we have a floor. And I created this work surface that's, let me actually, just so it doesn't, I'm going to delete that. Okay. I created a surface that is, I just copied the floor surface, which is the bottom of the extrusion that I made for my massing, and I copied it, placed it on a layer I'm calling work surface, and I just made it a little bit smaller. I do that just because I don't want it poking through the walls. Okay, so to run a daylighting simulation, similarly to the radiation map, we need to identify what is going to block the sun. So that's going to be our context, like we had before. The site I'll turn back on. We've already got materials on that site, right? But now we also need materials on the opaque portions of our building. So I'm going to select, oh, it's on. I'm going to go to my Climate Studio Materials, come to my opaque, and I'm also just going to call this concrete of some kind. So now the simulation knows that these surfaces ought to block the sun. The next step then, I've got materials on layers. Now I've got to add areas, and that's a work surface, like I was saying. This is for daylighting. We want to know where the light is hitting surfaces that people will be using to either I guess the simplest thing is to call them a work surface. So like a desk is a work surface. So the light will be reflecting off the desk into your eyes, and so that's the height at which we want to measure the amount of visible light interacting with your eyes. So I'm going to add an area. Actually, let me go back to this. I'll just select. So I said I made this work surface, so I'm going to select that object there, and I'm going to make it a work surface. By the way, let me go to wireframe. If you do that and it doesn't work, or if you just see a black surface, what happens sometimes is that your surface will be flipped. So there's this little Analyze Direction tool here. If I click on that, you see that this surface is actually going up. That's what the arrows mean. Let's see. I just flipped it. I'm just showing you that you can do that. So I'm trying to get this tool to I was just showing that I can analyze the direction and then I can flip the direction. Okay, so this is our work surface. Oh, I didn't actually show you, I think. Let's edit it. We have a sensor spacing. I'm going to leave that at 5 feet. There's an inset, so you'll see that the black dots are coming in 1.5 feet from the edge. And we're setting this at 2.5 feet. By the way, I am in feet for my units. So it's 2.5 feet up above the ground, so like at a desk height. Okay, so we now have areas, we have materials, but we don't have the materials for glazing. So let's just go ahead and I'm going to So this is going to be a glazing layer. So if I put on this layer, I come and I change my opaque materials to glazing materials. I'm going to start with something that's a very high visible light transmittance, which means it's letting in a lot of this visible light we're talking about. Okay, so now I should be ready to, I'm going to turn my sight back on because that's going to affect the amount of sun getting in there, and I should be able to run my daylighting simulation now. Okay, let's just look again at this, what I selected. I selected daylight availability. Select LEED 4.1 option 1. LEED is a certification standard. Don't worry about that at all. There's a bunch of stuff here that we don't need to know right now, SDA and ASE. We're going to select average lux, and we said that lux is the amount of light coming off of a surface that an eye will see. Okay, so I see one thing I did that I forgot I don't want to do. I'm going to go back. But anyway, this is our results. We have a gradient here of light coming in. It makes sense because this is the south wall. More on the south, less of this. This is a huge piece of glass, but it doesn't. We're getting more light here than there, obviously. One thing I did though, if I go back to my glazing, so I chose this glazing here. I'm going to select shade material. I want to put no shade, and I would like you to not select shades right now. Shades are part of a certification protocol that we can utilize, but I think as a baseline design, if we're using shades, in other words, so that to get this result, my glass was only unshaded 33% of the time. So that means that most of the time when people are during the day, this glass is completely covered in shades. That's pretty bad design, I think. Anyway, so I'm going to rerun this without the shade. I'm not even, yeah, I will save the first one. I'll call that daylight availability shade. And you'll see now we have a much larger amount of sun than we did with the shades, because the shades were just closed most of the time. So it's very deceptive here, that this first run. Okay, so what does this mean? Well, clearly we have a little room. I think, how big did I make this? This is 30 by 30 by 15 tall, so it's a small little building. The target, if this, let's say this were an office, our target lux for this office would probably be about 500, and we're at 21,000 here, so we have just way too much. I can change this value down here to something, and so I can see there is actually a gradient here, but this is just way too much overall. So there's things I can do. I can change the type of glazing. I can change the amount of glazing. That's what I'm going to do first. I'm just going to come and switch to this. Remember, this is the second type of the second glazing profile is smaller amount higher. I'm going to add that same glazing material without the shade. Let me make sure I did turn that off. Yep. Run this again. DA full glaze. And so now we see that quite a difference between the full glazing and the partial glazing. We still have a lot up front here, but about a third as much. Makes sense, it's about a third much glass. And back here in the back, we're actually getting something that would be getting close to what we'd want. Okay, so that's the basics. Let me name this DA. I'm going to call this top light. Okay, now let's talk about glare. Very simply, the concept of glare is something you already know. It's if you look directly at the sun, it's uncomfortable, right? That's glare. The sun can also bounce off of surfaces and cause glare by reflection. So we have heat from the sun that we talked about in the radiation map. We have visible light, which is about the work we're trying to accomplish, and so we try to bring in the right amount of light for whatever it is we're doing. But even if we have the right amount of light, we could have discomfort, and that's glare, and so we want to look at that separately. So there's another simulation workflow for that called annual glare. But it uses, let me go back to, if I set this yet, if I go to my results tab and I hit the white arrows, I can turn off my results. I'd already done this, I guess. I practiced this before I ran this first video, or I set this up. So we can use the exact same setup for a glare study as we did for a daylighting analysis. All we have to do is add a work surface if we didn't already have one. Where we can set an occupancy time, but you can just leave the presets for these probably. What you end up with when you start a glare study is on this work surface where we're looking at let's just turn these back on so we'll remind ourselves. I'm going to go back to my results. So on this same work surface now, we have these little pizza pies, and these are views. So, if this one is we're looking straight out to the south, this one we're looking back into the building. And if I'm ready now, I can just run it. If I run this simulation now, and actually I'm going to go back and change to more glazing. I'm going to have that glazing on. Let's make sure that it's still, yep, there it is. It's still got that same starfire. I'm going to run my glare study. Simple as that. You see that we have a lot of red, and typically red means it's high, and this is high. If I select one of these pizza pies, I can come over and see. So we're at 80% intolerable glare. In class, if somebody wants to ask me, I can explain how that metric was created. But the point is here that the way I use glare studies is I sort of get my daylighting to a level that I like it, or that I think is pretty good, and then I try to go see if there's problem areas. And so let's see what's going on here. I'm going to choose this. We've got. If I choose that pizza pie, I see it's still a lot of intolerable glare. Let me get off it. So if I don't have anything selected, this is what this window looks like over here. If I select a view, you see this little camera shows up and this little black dot shows up. What I'm doing here is selecting a day. So here I'm in January. I'm going to select a day in January. I'm just trying to select a day that I know that the sun is going to cause that glare. So if I select January. At about January, I don't know, it's like first around noon. And I click on this little camera. This window shows up. Now there's some playing around you're going to need to do here. But what are we looking at? We're seeing the sun, and the reason we're seeing it with that size is because of this, whatever this is set at, this range determines the size of the solar disk. So I'm saying you have to play around with it. But the point is, we're looking out that window. We can see that the context building is blocking the sun a lot at that point. But we're still getting a lot of direct sun coming in, which is what we thought, and we have this intolerable glare situation. So what can I do? Well, I can stop this. And come back and select a let's see if I try now a light shelf. So I put this, let me ghost it. Right, so now I've got that glazing out there, but I put a solid material as a shelf inside. I gave it a color, and that's actually a white ceiling color. Now let's run. Wait, did I not save my other glare? Let's see. I didn't. So I'm going to name this glare 1. Okay. Let me go back to the wireframe. Okay. So now I'm still looking at that same place. Let me go back to these. I want to go January. Just playing around here. So it remembered where I was in terms of the placement of my time day choice. Now you can see that that light shelf has done a lot to block the sun. So let's see if I can. Okay, so I'm going to clear the rendering and run it again. Oh, actually, and I'm going to turn off the light shelf. I'm going to run it. And now this was the original, right? Now I'm going to stop it and turn the light shelf on and rerun it. I think I have to clear it. No, there it is still. So we can see then that what we're doing here is adjusting physical parameters in the model and quickly seeing how they affect the solar orb at a certain time that we're looking at. And again, the point is that I'm trying to solve a specific problem for a specific time or day. So if I stop this and I come back out, I can try a different. Let's look this direction. We'll do it at the same time. So that's a different view, right? We can take off the light shelf, see what it does. So that's the workflow for this. Now, of course, and then if we get something we like and we want to try to see what its actual effects are, we can turn on the light shelf, make sure it has a material, and run this again. And we can see that there was a change. We have to come in and actually click on these to see the differences. The largest change was in the back, it appears. And by the way, we're not. One problem here with what we're doing is we're not affecting any of these the glare at the front here with that light shelf. That's why we might have wanted to run it this way. Like, what if I take this actually maybe even just do it in the middle. We could try that. Anyway, I'm just trying to show you how to use these tools. We can talk about it in more detail in class. But you see quite a big difference there. If we go do a radiance render, now for that same, I think this was probably something like this, right? Yeah, we can even see there's a drastic difference. I'm not sure we're even going to see the sun there now on that day. And right, we've got it pretty well. There's much less light coming in, of course, but there's very little direct sun. Um, the last point I want to make, and again, I'm not trying to. There's a lot of work to do to learn more about how to actually read these simulations. Got to go step by step. But remember or realize that they all have different functionalities. The great thing about the daylighting and the glare studies is you can go either annual, so this is an average, or I can go to a specific day. So I can study in a lot of detail by running a single simulation. I can learn a lot about any time of the year that I want. And likewise with the glare, I can just view, like for this last one, if I go into the summer, there's no glare at all. If I'm here in the first one, there was still a lot of glare in the summer. So if I'm switching to individual days and times, I get a lot more information. All right, so in review, we did daylighting. I'm sorry, we did site analysis, which is wind and sun. We did right. We did. Actually, I think if I turn off, yeah, just got to play around with what are the best settings to get the best visuals. We did site analysis, wind and sun. We did radiation maps and talked a little bit about how those work. We did daylighting analysis, where we're looking at how much daylight is coming in to a building and as opposed to heat, and we looked at glare. All right, so give it a shot for your assignment. Bring something in to discuss and to work on. It doesn't have to be perfect, but make sure you do have something that we can try to improve.